Welcome everyone to this topic on decorators. We're going to discuss a more advanced Python concept, which is the decorator. And decorators allow you to, quote, decorate a function. Let's discuss what that word decorate actually means in this context. Imagine that you created a function. Here we're representing it by just a simple function. It does some simple stuff and then returns something. So you create this simple function and now you want to add some more functionality to it, or in other words, add more code. What you could do is take your original simple function, then add some more stuff to it, keep doing the old stuff, and then return something. But this idea of adding new functionality basically represents a problem, because you have two options here. Either you can add the extra code, otherwise known as adding functionality to your old function, but then you have a problem of not being able to call your original function. You've edited it in some way with that new functionality. The other option is to create a brand new function where you copied all the old code and then added new code to that. The problem with that, though, is now you had to recreate the entire function over again. Even though it's just a copy and paste, it's not ideal that you had to actually make another function. But what if you actually then wanted to remove that extra functionality at a later date? What we would have to do is delete that function or make sure you don't call it. So deleting it manually, making sure you don't have the old function, there's got to be a better way. So what would be nice is if you had an on-off switch where you could quickly add that new code or add that new functionality and then turn it back off again. This is where the decorator comes into play. Python has this concept called decorators that allow you to quickly tack on extra functionality to an already existing function. And then if you no longer want that functionality, you just delete one line from the decorator. So they use the @ operator and are then placed on top of the original function. So you can easily add on or turn off extra functionality with a decorator. So you just take your original simple function and then you have some decorator which connects to some extra code, and then you can add in extra functionality. Then if you don't want that extra functionality, you just delete that @ some decorator line on top of the function. So this idea is pretty abstract when you actually practice it with Python syntax, because it's kind of this mysterious one-liner here on top of your function. So what we're going to do is we're going to go through the steps of manually building out a decorator ourselves to show what that @ operator is actually doing behind the scenes. And we're also going to learn about some concepts such as passing a function within another function. We're going to go step by step and build this out very slowly. So let's open up a Jupyter Notebook and get started. Okay, let's start off by actually building out our own decorators manually. We'll need to review a few concepts though, and introduce some new ones such as assigning functions or passing in functions into other functions. So what we can do is create a simple function called def-func, and this is going to return 1. So I can call that function and execute it, and I get back 1. Remember, we also discussed that if you just say func without open and close parentheses, you'll get back the information that, hey, you have a function here. You won't actually execute the function. That means we can actually assign functions to other variables and then execute them off that variable. So let me show you what I mean by that. For example, I will say create this hello function that returns back hello. So I can execute hello, or I can just ask, hey, hello, what is that? Well, it's assigned to a function. I could then say greet is equal to hello, and Python won't complain. In fact, now check out what I can do. I can say call greet, and it returns back the string hello. So what we want to ask ourselves is greet just pointing to hello, or has it made its own copy of the hello function? We can easily test that by deleting hello and then seeing if we can still call greet. So right now, I can still execute hello. I'm going to delete hello. And if I try executing hello now, it'll say, hey, hello is not defined. Makes sense, we just deleted it. Now let's see what happens when I call greet. So greet still returns hello. So even though we deleted the name hello, the name greet is actually still pointing to that original function object. And it's important to know that functions are objects that can be passed into other objects. So now let's show an example of passing in a function within another function or calling functions within another function. And this is going to tie in a lot with that scope and nested statements lecture that we had previously. So I'm going to make a couple of new cells here just to clear that screen. And let's create a function called hello. And it takes in a name. We'll have the default name be Jose. And this simple hello function is going to say the hello function has been executed. So right now, if I call hello, it just says the hello function has been executed. Makes sense? Now let's define a function inside of this function. I'm going to now say greet. And what this does is it just, it's going to return. So notice I'm using return, no longer print. And it's going to print \t, that's a escape character for a tab. And it'll say this is the greet function inside hello. So if I rerun these cells, I still just get back hello function has been executed. So let's think about what's happening here. I have this function hello. It takes in some default name by Jose, and it just prints out the hello function has been executed. We're actually not using the name yet. Inside of this function, I'm defining another function called greet. And greet returns, this is the greet function inside hello. Notice here, I'm just defining greet. I'm not actually calling it. So let's call it. Outside of greet, I'm going to print greet. Notice I'm printing it because greet returns back this string. So now when I run this, I get back hello, function has been executed, and then I get back tab, this is the greet function inside hello, because we defined it inside hello, and then we executed it inside hello as well. So let's define another function inside hello called welcome, and we'll do the same thing. We'll say return tab, this is inside, we'll say this is welcome inside hello. And then after greet, we're going to execute welcome. And it's really important here that you pay attention to the indentation because it's really easy to mess these up. I have the indentation here for hello, and everything else here is lined up. And then I have these two lines indented because they're part of the greet definition and they're part of the welcome definition. I don't actually call greet and welcome inside of these functions. Instead, I call it only inside hello. So notice here how these print statements are lined up with hello. You can always copy and paste from the notebooks in case you're getting any sort of indentation or syntax errors. So when I run this, I get back hello function has been executed, and we have these tabs here to kind of show that the greet and welcome function are actually inside the hello function. And at the very end of all this, I can still say, this is the end of the hello function. So I run this, the hello function has been executed, I define greet, I define welcome, then I actually execute greet, execute welcome, and print this is the end of hello. Now something to notice here is that greet is defined inside of the hello function and welcome is defined inside of the hello function. That means their scope is limited to the hello function. I can only execute greet and welcome inside of hello. If I try to execute them outside of this hello function, for example, if I try to call welcome, it says, hey, welcome is not defined, which makes sense because it was only defined inside of this hello function. And as long as you didn't define greet earlier, it will also end up being an error. So here we have this idea that greet and welcome, their scope is limited to hello. But what if we want to access these functions outside of hello? What we could do is have the hello function actually return a function. Remember that up here, we were able to assign functionality in this manner. It'd be really cool if our hello function, instead of just printing out the execution of greet, it returned greet. So here's what I'm going to do. I'm going to delete these 3 lines, and then I'm going to print out, I am going to return a function. And we'll say if the name is equal to Jose, return greet. Else, return welcome. Okay, so let's think what's going to happen here. Right now, my default name is Jose. I print out hello function has been executed. Then I define 2 functions. One's called greet, one's called welcome. I print out, hey, I'm going to return a function. And then we say, hey, if the name was Jose, return the greet function. Else, return the welcome function. What that's going to allow us to do is it's going to allow us to return a function which we can then assign to a variable, just like we did earlier up here. So let's see an example of that. We're going to say my new func is equal to hello, and we'll pass in the name Jose, which is also the default name, so you could just say hello. And I get printed out, the hello function has been executed, I'm going to return a function. So because the name was hello, this function, after doing these two print statements, it actually returned back the greet function, which was defined inside of hello. And now, if I call my new func, notice here it says function main.hello.locals.greet. So it's actually now pointing to that greet function inside hello, and I can execute it, and it returns back the string. Tab, this is the greet function inside hello, which I can then print, just like we did before, to actually see the string itself. This is the greet function inside hello. So this is the idea of being able to return a function within another function. Let's see one last very simple example. I'm going to have a function here called cool, and what it's going to do is have another function inside of it called, let's go super cool. And this is just a string. All this function does is it returns back, I am very cool. And then this function cool is actually going to return super cool. So I can say that some func is equal to the result of executing cool. Remember that cool itself returns super cool. So now some func is actually that super cool function. And if I execute it, it'll say, I am very cool. So this is just a simple idea of having a function, defining a function inside of that function, and then returning that function. And we're going to use this as our idea of building out a decorator. The last thing we need to think about is actually having a function as an argument. With the idea of being able to return a function and assign it to something, and then passing in a function as an argument, we'll have all the tools we need to actually create our own decorator. So let's quickly see an example of passing in a function as an argument. I'm going to say hello, and the hello function now is just going to say hi Jose. So we have that function hello, and I will create another function called other, and this takes in some defined function. So notice here, this is just a variable name. I could have called this whatever I wanted. And what it's going to do is say print other code runs here, and then it's actually going to execute that function. It'll say take in that function and open close parentheses, execute it. So what does this mean? It means I'm going to be able to actually pass in a function into this other function, do some stuff, and then execute the function. This is known as passing in a function as an argument. Previously, we just saw how we could return functions and then execute them when we assign them to a new variable name. Over here, we're going to see now how we can pass in functions into another function. So this is pretty cool stuff. We'll say other, and I'm going to pass in hello. Something that's key to notice here is that I'm passing in hello. I'm just passing in the raw function hello. I'm not executing hello. So just to make it clear, there's hello when you just pass it in, and then there's hello when you execute it. I just actually want to pass in the raw function because this raw function is going to be executed inside the other function. I don't want to actually execute the function here. So I'm going to say other, pass in hello. So I don't have open and close parentheses because I don't want hi Jose. I want to actually pass in the main function there because other function is going to then execute it for me and say hi Jose. So think about what you expect to see when you run this cell. I should be seeing other code runs here. Then the other code is going to grab hello and execute it in this line and print out the result. So then I should see hi Jose. So I should see other code runs here and hi Jose when I run this. And that's exactly what we see. So now we understand that we can return functions and we can have functions as arguments. With those two main tools, we're actually going to now be able to create a decorator. We have the tools we need to quickly create some sort of device that is an on-off switch when we want to add more functionality to a decorator. So I'm going to create a couple new cells here and finally get to the part where we create a new decorator. I will say def new decorator, and this takes in, we'll call it original function. And inside of my new decorator function, I'm going to say wrap func. And what this wrap func represents is the extra functionality that you want to decorate this original function with. So what this does is we're going to print some extra code before the original function. And you can imagine this doesn't have to be a print statement. It could be a bunch of other code. Then we're going to take in that original function that was passed and execute it. And then we're going to print some extra code after the original function. So notice what we're able to now do. We're passing in the original function, adding in some extra code before it, executing the original function, and then adding some code after it. Then what we're going to do here is just return the wrap function. So you can kind of think about this as the idea of a present with some wrapping paper. The actual original function is the present, and then we're going to essentially put it inside a box and wrap around it, which is why this is called decoration. So you're kind of decorating this function with some wrapping paper, where the wrapping paper is just the extra code that can go on top of the function, before it, or after the function below it. So this is a function, just like we did before with hello and greet, except now the names reflect what's actually happening here. We created some new decorator function. It takes in an original function, and inside of this, we define this wrapper, which has some extra code before it, executes that original function, puts in some extra code after it, and then returns the wrap function. So then, I'm going to create a function here, and this function is going to need a decorator. So that we call func needs decorator. And what this does is it prints out, I want to be decorated. So the idea is we want to add in some extra functionality to this original guy. This function needs a decorator. Right now, if I just call function needs a decorator, I just get back, I want to be decorated. What would be really cool is if I could somehow add in some extra code using the framework that I built out here. And this is actually really easy. All I need to do is say, grab my new decorator and pass in this func that needs a decorator. Because remember, it's going to take the original function here. So let's say func needs a decorator and pass that in. No, I'm not executing it. I'm just saying new decorator and then func needs a decorator. So that I can call this my decorated function is equal to this function that needs a decorator passed into the new decorator. So what's going to happen is when you pass in this original func needs a decorator, it says, okay, that's the original function. And then inside of this wrap function, we add in some extra code before it. We execute that original function. So we would print, I want to be decorated. Then we would print out some extra code after the function. And with this new defined wrapping function, we return the wrapped version of this original function, which is all that this line is doing here. It's taking in that function that wants a decorator, wrapping it in some extra stuff, and then returning back a wrapped version of that function. So I run this, and then I can call my decorated function, and I see this, some extra code before the original function, I want to be decorated, and some extra code after the original function. Now what we did is actually quite complicated because I had to define all this stuff here. But there's a special syntax for what is essentially this line, and the special syntax is that @ operator. So if I wanted to actually create new decorator, what I could do is say @new decorator, say def, and then, well, let's just actually grab the original one. We're going to copy this here, paste it here, run this, and now when I call func needs a decorator, I get back some extra code before the original function, I want to be decorated, some extra code after the original function. So notice what happens here. This keyword of @new decorator, when you put it on top of a function, it just says, okay, I'm going to pass this function into this as the original function, I'm going to do something to it, add some extra code after, add some extra code, add some extra code before it, call the original function, add some extra code after, wrap that into a nice function, and then return that wrapped version. That's all the decorator is doing here. It's essentially wrapping it around. Then if you ever want to turn this off, well, it's easy. You just comment this out, and if you were to rerun this, you no longer have that wrapping. So this is now your on-off switch, having that @ symbol there. Realistically, you really won't be having to do this sort of coding of a new decorator, the wrapping function, etc. You won't have to worry about that. What you will be doing is you're going to be using a web framework or someone else's library and just adding in these new decorators to maybe render a new website or point to another page. So they're really commonly used in web frameworks such as Django or Flask, which is why it's important to understand behind the scenes what the decorator is actually doing. Now that you understand behind the scenes what it's doing, you can simply just use this abstract idea that when you tack on this new decorator, it's just decorating your function with some extra code. All right, I know that was definitely a lot to take in. You really want to check out the notebook for this one where it lays out all the steps with some explanatory text for you. If you have any questions, feel free to post the Q&A forums. I'll see you at the next lecture.